Woohoo! We are live. This is Math 60 Intermediate Algebra, and we are in the middle of solving simultaneous equations or simultaneous systems of equations. And 3.1 was a section all about graphing, and now 3.2 is going to be where we approach these solutions using algebra. Now, if you are in intermediate algebra, I'm going to assume that you have seen some of this before. It would be part of a beginning algebra or algebra 1 class. So I'm hoping this is review. And if this is not review, you may want more practice with this first part. The first thing we're going to do is substitution. I only have 2 examples because, again, I'm assuming a lot of people have seen this before, and so it's just going to be a refresher. If this is brand new, or if you're just really feeling rusty, come talk to a teacher, go talk to your tutor, ask people on the street, ask people on the bus, make friends, have a math party, invite people into your life who can help you with substitution, because we're all really eager to help you with this. So I can give you lots of examples. We can go over it. We can review as much as you'd like. So having said that, let's go ahead and get started. We are going to have Matt Damon looking over our shoulders because we're still trying to decide, are we in a, in a single solution? Are we in a, where are we going? Parallel, so no solution, or are we in infinite solution? So happy Matt Damon, sad Matt Damon, happy Matt Damon. Okay. So these are algebraic, which is a fun word to say. You should say that out loud when no one's around, or when everyone's around. Maybe get everyone saying it. It's fun. So these are algebraic solutions to systems of equations. Again, I've got 2 equations, and generally I'm going to have an x and a y, or 2 variables of some sort. And these are actually going to be solve and check. So I'm going to solve it, and then I'm going to double check my answer. Now, this is going to be elimination by substitution or substitution. So this is, we're going to take one equation and put it inside the other equation. So I have an equation 3y plus x equals 4. Okay, that's lovely. But I also have an equation x equals 2y minus 1. This equation is solved for x. And that's what you need. The first step, step 1, to use this particular method, you have to solve one equation for one of the variables. It turns out it doesn't matter which one. So you can make this as easy on yourself or as hard on yourself as you'd like. I happen to already have one, x equals 2y minus 1. Ta-da! So that step is already done. Step 2, substitute. So what I'm going to do is I'm going to take this equation, which I will call the green equation, and I'm going to substitute it into the other equation, which will be the pink equation. So I've got 3y plus x equals 4. So this is my pink equation. And since I have x equals right there, see how I have x equals right there? Where the x is, I'm going to expand this. I'm going to put a big set of parentheses. So I've got 3y plus something equals 4. Now the outside equation is still the pink equation. This is still the pink equation on the outside. But what I'm going to do is I'm going to take this x, which also equals 2y minus 1. So this is the information from the green equation. And I'm going to say in place of x, I'm going to put the 2y minus 1, which was part of the green equation. And you see how now I've got an equation. It's kind of like the Brady Bunch. I brought both families together. So I got 2 equations in one. It's two equations in one. So let's go ahead and look at what the benefit is, because that was a lot of work. Why did I do it? Well, if you look at this equation, I've got a y and no x's. Whatever I substitute for, that variable will disappear. So now I've got a single variable. Oh, wait, I know how to do this. I can add 3y plus 2y minus 1 equals 4, or 5y minus 1 equals 4. Add 1 to both sides. 5y equals what? 5. I get 5y equals 5, or divide by 5, y equals 1. Now here's the thing. In a normal equation, I'd be done. Y equals 1. The problem is now I still have to find the other. So step 3, find the other variable. So I happen to know right there that x equals 2y minus 1. That was my green original equation. And I know y equals 1. So x equals 2 times 1 minus 1, which is 2 minus 1, which is also 1. So I've got the solution. X equals 1, y equals 1, or 1 comma 1. Now, I don't know if I want to take you to Squishy Town. Let me see if I can fit in the check here, because if I can avoid using a second piece of paper, I'm going to try. So let's go ahead and check. Now remember, always write check when you're going to check to make it easier for your teacher to find it. I'm going to check the original equation. So 3y plus x equals 4, and x equals 2y minus 1. So over here, I've got 3 times 1 plus 1. Is that equal to 4? And yes, it is. 3 plus 1 equals 4. Woohoo! Okay, how about 1? Is that equal to 2 times 1 minus 1? Yes, it is, because this is 2 minus 1, which is 1. Yay! Like that. So now I ask you, is Matt Damon happy? He's asking you too. He's like, am I happy? And the answer is yes, you are so happy, Matt Damon. Yay! Why is Matt Damon happy? Because we got a solution. It's a single solution. It's a very particular kind of spaceship. It has to follow these rules. X equals 1, y equals 1. Don't know what that means in the spaceship world, but he's a happy guy because we managed to get him a spaceship, and he won't get too hot and he won't run out of oxygen. Yay, Matt Damon, we saved him. Like, this could be yet another blockbuster movie starring Matt Damon. Okay, so that was the first one. Yay, let's go on to the second one. Oh no. Yeah, this is welcome to intermediate algebra. Hey, the gloves are off. And this is just putrid, and there's no excuse for this kind of algebra, except that I wanted to show you, and you know it's always going to go well, and the teacher already wants to grab a second piece of paper. This is going to be a 2-sheeter, I think. And so, oh my goodness, we're having trouble with the focus. This is getting more and more exciting. Let me see if I can fix that. Oh my goodness, I'm making everyone sick. Yay! It's like it's breathing. It's like, stop. Stop. Did we get it to stop? Well, that was exciting. My webcam is possessed. Ooh, spooky webcam. Okay, so let's go back. Maybe the webcam was trying to save you from the fact that this is a system of 2 equations, except the first equation is all about the fractions, and the second equation is all about the decimals. So step 0 here, not even step 1, is to clean up the equations. We just need to. So I've got 2/9 x minus 2/9 y equals 2/3. And I look through there and I see a common denominator of 9. So I'm going to multiply everybody by 9. 9 over 1 times 2/9 x. 9 over 1 times 2/9 y equals 9 over 1 times 2/3. Bring in my red pen. These 9s cancel. Woohoo! These 9s cancel. Yippee! This 3 and this 9 doesn't really cancel, but it's close enough, so we're happy. Okay, right here I got a 2x. Right here I've got a minus 2y. And right here I've got 3 times 2, I got a 6. Now, can I simplify this further? Could I divide both sides by 2? Absolutely. But given that that's not always an option, I'm not going to do it. I'm just going to continue with it like this because you wouldn't necessarily see that. But if you would like to take advantage of it, when you are doing these problems, all the rules that used to apply still apply. Just because Matt Damon is involved does not mean you cannot multiply or divide on all sides. So make sure you're consistent, but you could divide by 2, divide by 2, divide by 2 if you'd like. Okay, the other equation, 0.1x equals 0.2 minus 0.1y. And what I'm going to do here is I'm going to multiply by 10. So 10 times 0.1x equals 10 times 0.2 minus 10 times 0.1y. So far, so good. So this gets to 1x equals 2 minus 1y, or x equals 2 minus y. Okay, not too bad, not too bad. So far, so good. Now let's go to step 1. Solve for one variable. And you'll notice I already have it done by the time I've cleaned this up. And you know what I'm going to do? I'm going to take a little moment because I've done this in the past while you guys are thinking about this. I realize I didn't do my little show you that I have given out the 10s and the 9s fairly. Okay, solve for one variable in one equation. That's done. Yay. I didn't have to do very much work here. And there we go. X equals 2 minus y. Step 2, substitute. Okay, so I need 2 colors. So I'm going to go for blue and pink. So this will be my pink equation here, which is that one. And this will be my blue equation right here, which is this one. Okay, so I've got 2x minus 2y equals 6. There's my blue equation. So now I look at the other equation. I go, okay, what am I substituting for? I've got x equals. That tells me I'm substituting into the x. So I give myself room, give myself a lot of room right there. This is going to be substituting into the x. And then everything else stays the same. So the outside, the crunchy outside, the lovely topping is still the blue. But inside, I'm going to put the pink. So this is like, well, this is kind of like a genetically modified equation, right? I'm gene splicing. I'm bringing the best, so the tallest corn, mixing it with the sweetest corn, and we end up with the most delicious corn or something like that. Okay, so I know for some of you, I've just said don't to avoid math like the plague, and I apologize. So x, I'm going to substitute in there for x. X is also equal to 2 minus y. So wherever I see x, I can actually put in 2 minus y. So I'm going to put the 2 minus y in there. And then let's go ahead and see what I've got. I've got 2 times 2 is 4, minus 2y, minus 2y equals 6. So far, so good. Woohoo. Okay, here we go to the next page. Remember, I never do math in between pages. I need this one close because we're going to need it. Let's see. I get 4 minus 4y equals 6. Minus 4 minus 4. I get negative 4y equals 2. Divide by negative 4. And I get y equals what? You got it, negative 2/4, which is equal to negative 1/2. Take a look at that. Oh, sorry, you can't take a look at it. There's a shining light in your face. Sorry about that. Take a look at it now. Okay, so again, when we substitute for x, x disappears, so we solve for y. And so step 3 is to find the other variable. And a lot of wisecrackers would say, there it is, it's right there. So let's find what the other variable is equal to. So x is 2. Oh my goodness. Ah! My brain tried to write things too fast. My hands are not fast enough for my brain. 2 minus y. There we go. Okay. I know this is going to be nobody's favorite thing because y is already a fraction and it's just going to keep going. Fraction town is so much fun. Okay, so x equals 2 minus a negative 1/2, which is equal to 2 plus 1/2, which if you're just, you can get away with writing that. Or you can convert it to 5/2. Now, if you're not sure how to get from a mixed number to an improper fraction, then there are some videos. We went through it before in the very first chapter, or come talk to me or talk to a tutor. Okay, so I can switch to that. And here's the thing, let's look back at the original problem. The original problem is written both with fractions and with decimals, which means your answer could be in either form. You get to choose. So you could say 2.5 instead of a fraction. And in fact, this could be -0, so big or, -0.5, if that makes sense. Okay, so my two values are x equals oh my goodness, my poor brain. X equals 2.5, right? It's right there. And y equals -0.5. Or I could do it with fractions. X equals 5/2, y equals -1/2, and that would be 5/2, -1/2. And you've got your choice. And I know everyone wants to say, yay, let's celebrate. We're all done. We don't have to do anything else. Nothing else whatsoever. By the way, is Matt Damon happy? Yeah, he is. This is an ugly solution. Doesn't matter if the spaceship's ugly. He's going home. Yay, doing a little dance. Little Matt Damon dance. I imagine he dances like this. I don't actually think I've ever seen him dance. Dance. Full disclosure, I haven't seen the movie I'm talking about. I find it better if I'm going to use a movie and as an example for me not to see it. Okay, why? You're all asking, why? Is there a blank piece of paper? Aren't we done yet? And I will say, no, we're not done. Matt Damon may be having a party, but we're about to have a fraction and decimal party. Because what did the problem ask us to do on the very first page? Those 5 little letters. Check. Yay! So what were our values again? Our values were x equals 2.5 and y equals -0.5, or we could use x equals 5/2, y equals -1/2. Now, having both of those is going to be really nice because our equations are mixed, right? One of our equations is a fraction. So 2/9 x minus 2/9 y equals 2/3. So I think I'm going to go ahead and use the fractions to do this. I'm going to use these guys to check this one. So this is 2/9 times 5/2 minus 2/9 times -1/2. Is that equal to 2/3? So let's see. You're not allowed to clear fractions, but you are allowed to cancel. So I'm going to cancel this 2 with that 2, and then I get 5/9. I've got a minus, so this is plus, and then this 2 cancels with that 2, and then 1/9. Okay. So what is 5/9 plus 1/9? That's 5 plus 1/9, which is 6/9. Wait a minute. That's 2 times 3 over 3 times 3. Oh my gosh. Oh, look at that. Oh, wow. Bob's your uncle. Check. Nice. Okay, so that was, which of the equations was that? That was the blue equation. Blue equation is a check. Okay, so now let's try, what was the other one? Pink. The pink equation. I'm going to draw a line so I can see what's going on. 0.1x equals 0.2 minus 0.1y. Okay, and I'm going to plug in, for this one, I'm going to use the decimal forms. Okay, so I've got 0.1 times 2.5. Does that equal 0.2 minus 0.1 times negative 0.5? Now, here's the thing. In a check, you're not allowed to clear decimals. So even if I wanted to clear decimals, I'm not allowed to. So I'm probably going to pull out my calculator, or, 0.1 times 2.5 is just, it just means that you move the decimal point. But if you're not sure, 0.1 times 2.5, 0.25. Okay, so the left side is 0.25. Over here, I've got 0.2, and then I've got minus a minus, so that's a plus, and then 0.1 times 0.5. 0.1 times 0.5 is 0.05. And what is 0.2 plus 0.05? 0.25. Oh my goodness, look at that. The pink one checks. Check. Both equations check. Dancing time. Now is the time on Sprockets when Matt Damon dances. And we did it. That was substitution. Now, that was not enough substitution. If you were just learning this for the first time, you want to see a lot more practice. So you may want to look at, I've got some videos for substitution in Math 40. So ask me and I can show you those, or you can look around on, on the street or on the interwebs, find substitution. Matt Damon is dancing. And I'm going to end the video now. We're going to go ahead and do elimination next. And there are going to be a lot of videos. I just got to warn you, I want to give you a lot of practice, because elimination becomes something very important in the very next math class you take. So it's very excited. I'm excited. Matt Damon is excited. Everyone's excited. I will see you guys in the next video. Woohoo. Math on, guys.